Today we're going to check the driveline geometry. If you remember in one of the earlier videos, I think back number 12 or 13, something like that, I did it roughly based on the height of the front of the engine, measuring across the frame, at least to get the motor in the right spot. But the whole rear suspension on this thing has been changed. So I got a feeling that, very possible, that it's really not where it needs to be. So to measure this, you need to have the car at ride height. To do that, I'm doing two things. Because the car, I don't have all the weight on the front, I don't have gas in it, I don't have the rear bumper, any of that stuff in it. So what I'm going to try to do, or half the interior for that matter, so what I'm going to try to do to get it at right height is see the barbell weights I have in here. That is approximately 100 pounds. That'll get the back end, I think, about where it needs to be. And then I'm going to adjust my coil over front suspension. So all you got to do is loosen up this spanner lock. It's on the bottom, and then turn the spanner ring itself. This is a spanner wrench. Basically came with the front end setup, and then turn. Okay, so I got the front springs adjusted where I think they need to be, and I'm basically going to use a level to see if the car is at right height. And it's really close. The front is up. Oops, hold on. There we go. It is really close. The front is up just a little bit, but that's okay. Once the weight of the fenders and everything is on there, then it'll be at the right height. And one thing you got to remember is that to do this, you need to have the exact tires and rims and stuff that you're going to have on the car to make sure it's at right height. So to start taking dimensions, we need to get underneath the car. So what I did, so I can get underneath it, I just put it on some 4x4s so I can slide in underneath. Because we need to measure the pinion angle, drive shaft angle, and then of course the angle of the engine. So what I'm going to use for this is this here angle finder. Just a little magnetic angle finder, got it at Home Depot. I don't know, it's like 25 bucks or something like that. So the first measurement will be off the engine. What I'm doing is I'm taking it off the front of the crankshaft, which, you know, the transmission and everything better be in alignment with it. It's magnetic base, so I just put it on there until the numbers stabilize. At 84.7 degrees. And that's what we're gonna measure. So I'll put the angle gauge against the flat surface where the cups go for the drive shaft. And you can see that or not, it says 80, let's see, it says 83.9. So I put the drive shaft in so we can measure the angle of it, and it is 1.2 degrees. So here are the angles I measured summarized. Engine, drive shaft, and the rear end. The numbers circled are the ones that we need. Because how I measured the angle of the engine and the rear end, it was 90 degrees to horizontal, so you need to subtract the value you got from 90. So the engine is 5.3 degrees to horizontal, the drive shaft 1.2, and then the rear end 6.1. And you can see the little arrows I have by the numbers. It shows they're all pointing down, which means they're all sloping down. And you judge that by looking from the front of the engine and going back. If the back is lower than the front of the component, then it's in a downward slope. Now to determine if everything is okay, I have this online calculator from Spicer. They make U-joints, and basically you take those dimensions and you plug them into their calculator, and they'll let you know, or the calculator will let you know if your driveline angles are okay. Here's the calculator. I'll put a link or something out on the video for you to get here, although if you just Google Spicer, you can get it right from the home page. So let's go ahead and put in the numbers that we have here. So the driving member, which is the engine, was at 5.3, and it's angled down. and the drive shaft was at 1.2, and it's angled down, and the rear end was at 6.1, and it also is angled down. So here's the numbers I get: 4.1 and 4.9 for the operating angles. Operating angle 1 is from the engine to the drive shaft, and operating angle 2 is from the drive shaft to the rear. On the website, they have some basic rules to follow for the operating angles. Rule number 1 is that the operating angles at each end of the drive shaft should always be at least 1/2 degree. Rule 2, the operating angles at each end of the drive shaft should always be equal within 1 degree of each other. And rule 3, for vibration-free performance, universal joint operating angles should be no larger than 3 degrees. My operating angles calculated at 4.1 and 4.9 from the online calculator. So how do I stack up against these rules? It's as follows. So rule number 1 has to be greater than or equal to 1/2 degree, each of the operating angles. And you can see 4.1 and 4.9 is greater than 1/2 degree, so check on that. Rule number 2 have to be equal within 1 degree, and I believe this is how you calculate it. Subtract the 2, and I come out with 0.8, so check on that. And rule number 3, I have to be greater than or equal to, well actually I think, less than or equal to, and I think it's really just less than 3 degrees. And 4.1 and 4.9 certainly do not meet that. So I've got stuff on too much of an angle, and I need to make some adjustments.
So to try to correct the driveline angles, what I wanted to do was tilt the rear end down, the pinion down, and then try to level out the motor a little bit, which I was able to do. Let me show you what I did. To reduce the angle of the motor was I raised up the back, and you see the stack of washers that are underneath the transmission mount.
For the rear end, I have adjustable upper control arms. So all I had to do was unpin them up here at the top, and then I basically shortened them to bring the angle of the differential down this way to reduce its angle. Okay, at the motor, we are now 85.3. It's actually bouncing back and forth between 3 and 4, but it's 85.3. And then the angle on the drive shaft is 2.0. Numbers. I'm starting from the front, 85.3, which was measured on the angle finder, turns into a 4.7 degree angle on the engine. The drive shaft is now at 2 degrees. And then the calculated angle at the rear end is 3.9 degrees. Put the new numbers into the calculator. So the first one is 4.7. The drive shaft's at 2, and the rear end is at 3.9. So here are my new operating angles, 2.7 and 1.9. Let's run those through the 3 rules and see where we sit. So with the new angles, let's go through the rules. Rule 1, greater than or equal to 1/2 degree. 2.7 and 1.9 certainly adhere to that, so check. Rule number 2, and again, I believe that this is how it's calculated. The differential between the two should be within 1 degree. I'm at 0.8, so check there. And now, rule number 3, which I had an issue with, should be less than 3 degrees. I'm at 2.7 and 1.9, so I'm within those limits. So everything's good.
So everything worked out. It took me 2 tries on the rear end, adjusting those upper control arms to get the right pivot on the rear end, but wasn't that bad to do. A lot easier to do it now without the gas tank and all that stuff, and just that much more room to do it. A couple things to note is, man, be sure that this thing's at ride height on the ground, because the frame flexes and such, so get it on the ground, ride height. I was lucky with the coilover shocks in the front that I could really adjust it to an actual ride height without all the weight on the front. I'm I'm confident that I shouldn't have any vibration problems and everything should drive fine.